Good morning, good evening, or good afternoon. Thank you for joining us today for today's session of the Azure webinar series, Containerize Your Applications with Kubernetes on Azure. Before we get started, we'd like to go over a little bit of housekeeping. We have subject matter experts with us today who will be answering your questions in real time, so please use the Q&A window. If you have any questions throughout the webcast, we'll be happy to answer those. You will receive a copy of the presentation in your email within about 48 hours, so please keep your eye on that as well. On the top right corner of your webinar console, you're going to see a resources box. And any of the URLs that are mentioned today, they will be available for you there. Our speaker today is Gabe Monroy. He's the lead PM for Azure Cloud Native Compute. Gabe, I'm going to hand it over to you.
Hi, everyone. My name is Gabe Monroy. I'm the lead program manager for the Azure Cloud Native Compute team. So I look after services like our Azure Kubernetes service, Azure Container Instances, OpenShift on Azure, and a bunch of other developer tooling that we do in the upstream Kubernetes and container ecosystem. I also sit on the board of the Cloud Native Computing Foundation, where I represent Microsoft. So I'm really excited today to take you through the Azure Kubernetes service, show you some really cool demos, and talk a little bit about what we're doing with containers and Kubernetes on Azure. So before we dive into the slides, I'd like to show you how fast and easy it can be to get up and running with an application using Azure here. So what I'm going to do is use this new DevOps project solution from Azure. What DevOps project allows you to do is take a wizard-based approach to deploying a new app on Kubernetes. So here I can start by selecting a language. Let's select Node. Let's use the express.js framework. We're going to target this at our Kubernetes service. And here at the top, I can either select an existing Visual Studio Team Services environment or create a new one. In this case, I'll create a new one. I'll call it AKS Webinar. I will create a new project called AKS Webinar. And then I'll go ahead and hit done. What will happen after I do that is this would create a complete Kubernetes cluster, 3 nodes with default configuration, but it would also set up a VSTS project as well as a CI/CD pipeline with an example application. And I can show you how this looks by navigating here over to Resource Group and showing you a version of this that I just set up before this demo. You can see that this has created a CI/CD pipeline for me automatically through VSTS. I have all my Azure resources, including the Kubernetes apps and the different services that are deployed, as well as application insights telemetry, like how many requests I'm getting, how many requests have failed. So you can get all that nice visibility. And if you click on this external endpoint, you can see, hey, look, we've got an application deployed and it's been visited a few times. So that is Azure Kubernetes service through the Azure DevOps project. Okay, so we're going to go through some material here today. We're going to start off with a quick intro, take you through the Azure Kubernetes service, review some top scenarios, and then we're going to go for a deep dive into the product experience. I really want to show you how AKS looks and feels inside the Azure portal, as well as show you how this works from an IDE. Then we'll talk a little bit about customer stories and some other bits around open source culture. So that's the agenda for today. But let's go ahead and start with an intro. I think the context here is incredibly important. Gartner claims that by 2020, more than 50% of enterprises will be running mission-critical apps and containers in production. I think that's a pretty impressive stat. It's also important to note that larger companies are leading the adoption at this stage. So I think it's safe to say that containers are, well beyond kind of the early adopter phase and are moving into mainstream adoption with large companies and enterprises really leading that push right now. Now, what's nice from the standpoint of customers is that, Kubernetes has really emerged as the leading orchestrator across the industry. There's a lot of reasons for this. It offers great portability portability across your on-prem environments, in the cloud. It's also extensible. There's a whole ecosystem of tooling that's being built up in and around Kubernetes, all sort of inside the Cloud Native Compute Foundation generally, but things like monitoring, how you do log aggregation, distributed tracing, all the stuff that you need to operate, distributed applications at scale is being built with Kubernetes in mind now. And that's important for customers. And then the last bit is self-healing. With distributed systems, you have to really embrace the concept that parts of that system can fail at any time, and making sure that the orchestrator that you use has great self-healing features, auto-scaling, auto-placement, things like that. That becomes incredibly important. Now, Kubernetes is something that we've offered on Azure for quite a while now. In its first permutation, the Kubernetes service was what we refer to as an unmanaged service. So users would submit their Kubernetes workloads to the Kubernetes API endpoint, but the master infrastructure, the API server, the scheduler, the controllers, and importantly, the etcd, which is like the data store for Kubernetes, the customers had to manage all of that themselves. This is in fact how Kubernetes works across sort of most IaaS providers, or if you were rolling it on-prem. This is not ideal because there's a lot of work involved in kind of maintaining this master infrastructure. So while you do get the benefits of Kubernetes, there's a lot of work, and you have to staff a pretty big team to make sure that this works in the wild. So what we've done here with AKS is that we've taken all of those hard parts and we've turned that into a managed service, right? So this offers automated upgrades and patching, HA, easy cluster scaling, through a slider in the portal. I'll show that in a bit. Self-healing across the board, control plane and the data plane, and sort of the node pools. Monitoring. And we also, interestingly, we offer this service for free. We believe that it's important for you to, not have to pay for the infrastructure to run your infrastructure. And that's something that, we were first to market in offering. Now, if you take a look at, some of the things that you have to do from do-it-yourself Kubernetes versus managed Kubernetes on Azure, you can see that things like cluster hosting, upgrade, patching, scaling, monitoring, and logging, these are all things that you have to worry about that are really undifferentiated work for you, the customer, right? There's not a lot of value to your business from being really great at performing cluster upgrades. And so we've seen this big shift in the industry and with Microsoft customers who are looking for a managed Kubernetes experience, and we've delivered that with AKS. So we've taken over a cluster hosting upgrade, all the sort of tasks, unglamorous tasks around operating this distributed system. And we've left you with a little bit of work to do on CI, how you want to perform the iteration cycle for how you build apps, what we refer to at Microsoft as the inner loop, as well as how you containerize your workloads. What we find in practice is that a lot of customers want control over these elements. They want to containerize in certain ways. They want to use their own tooling, be it for how to build or how to use security. And so you get the flexibility there and the ability to use Kubernetes APIs without the work involved in maintaining the cluster, carrying and feeding for that cluster. So next, I'd like to move into the overview of the Kubernetes service. So next, let's get into the overview of the Azure Kubernetes service. Now, what Azure Kubernetes Service is doing is simplifying the deployment, management, and operations of Kubernetes. Lots of different things that the service is offering. Ease of use for how you deploy and manage Kubernetes. You don't have to worry about how this thing scales. It comes with great security integrations like Azure Active Directory. And you get the ecosystem benefits of sort of the CNCF ecosystem and the open source tooling ecosystem around Kubernetes. Now, this has been extremely attractive to customers. Kubernetes on Azure usage has grew 10x over the last year. Our customers have grown over 5x over the last year, and we've had the service in operation for quite a while now. So these are actually quite impressive growth statistics. Now, if you take a look at, how are we making this easy? Why are customers flocking to this service? Well, we make this stuff easy to use, right? So if you think about the old way of how you would create a cluster, a lot of work involved there. With Azure, it's just AKS create. With upgrading a cluster, this is something I've had a lot of experience personally with. It's a lot of work to upgrade a cluster by hand. Folks like OpenAI, who we've worked with in the past, who when they have to upgrade a 2,500 node Kubernetes cluster, that's a really painful and time-consuming process. We've now turned that into a single command with AKS upgrade. And scaling is similar. A lot of work involved in scaling, especially on scale down, where you have to cordon and drain nodes to make sure that you're not interrupting users and in-flight requests. Well, we've turned all that into a single command with AKS scale, as well as a portal-based equivalence. Now, this is also true when it comes to containerized development. We've also made this part easy as well. With traditional models, you're basically on your own for how you define Docker files, Helm charts, Kubernetes manifests, things like that. With Azure, we offer the open source draft project, which allows you to draft init your environment, draft create to scaffold out a Docker file and a Helm chart based on what the tool detects in your source code repo, and then draft up to deploy the app to Kubernetes and begin working on it and iterating through your development cycle. We also offer sort of an enhanced version of Draft with Azure Dev Spaces, which I'll show you soon. The last thing I want to point out here is HTTP application routing. Now, a lot of folks are using Kubernetes in the wild to deploy microservice environments. Now, usually those microservice environments will have some part which needs to be exposed to the public internet. By using this HTTP application routing feature, which is just a toggle inside of AKS, you can get automatic exposure of select groups of applications in Kubernetes with automatic DNS, and a lot of work that didn't have to get done, for users here. So extremely compelling feature and something a lot of customers are quite happy with. The last thing I want to call out here is setting up CI/CD. We have this Azure DevOps project, which allows you to do this with a few clicks. Things like Azure Container Registry, geo-replication, you're a great add-on to that to make sure that you can get your CI artifacts published globally across Azure's massive footprint of data centers. And then we also offer integrated monitoring, so you can tell whether your deployments are actually working or whether you may need to roll back. Now, one of the big reasons folks are so enamored with Kubernetes these days is because there's this whole ecosystem of open source tooling and APIs. Things like Helm and Draft on the development side are in large part driven by folks like Microsoft with help from the open source community. But there's also things like Prometheus on the monitoring front. Tigera, who offers great network security options that are Kubernetes native. Portworx offers a terrific hyper-converged storage solution. Companies like Twistlock and Aqua are doing great stuff around container security, image scanning, and runtime analysis. Now, all this work in this ecosystem is something that you can take advantage of when you're using AKS. Not to mention the growing Azure support that we have across the board, whether it's in VS Code or VSTS, which I'll show you a little bit of, or sort of across the suite of Azure services. One of the things I'm particularly excited about is something called the Open Service Broker for Azure. What the Open Service Broker for Azure allows you to do is, through the use of a Kubernetes manifest, it allows you to bind the containers that are running inside of Kubernetes with different Azure services, automatically injecting credentials for things like username, password, automatically creating databases, in Cosmos DB or what have you. Very, very exciting development and frankly, a technology that we've seen a lot of traction with in the world of Cloud Foundry. It's just now being applied to Kubernetes through the Open Service Broker APIs. Now, when it comes to securing your Kubernetes environment, AKS offers a lot of different options here. We have deep integrations with Azure Active Directory and Kubernetes role-based access control. This allows you to use Azure Active Directory as your identity provider and Kubernetes role-based access control rules to restrict what folks can do to certain resources. We also have integrations with Key Vault that allow you to persist and sort of access keys from a secured location inside of Azure. We support VNet integrations deeply inside pretty much every part of AKS is VNet enabled at this point. And we also have a growing suite of compliance checklists, including SOC, HIPAA, PCI, and others more to come. Now, when it comes to scaling, and there's a number of technical solutions we have in the product. We have built-in auto-scaling at a few levels. The Kubernetes horizontal pod autoscaler will allow you to scale your containerized workloads. We also have cluster auto-scaling support, which will scale off of the pending pod queue inside Kubernetes. This is something that large customers like OpenAI have been extremely successful with. We also have this global footprint of Azure Data data centers. Many of you probably know that Azure has the most regions out of any cloud provider, and that's something that is very important when it comes to distributing applications with Kubernetes that need global reach. Through Azure Container Instances, which is our serverless container offering, we have the ability to do elastic bursting from AKS to containers that are hypervisor isolated and per second build in ACI. This is actually extremely exciting. We're the first to market with anything like this, and are now integrating this Azure Container Instances offering directly into AKS. You can expect more to come on that front. And lastly, the geo-replicated container registry. This actually, having your Docker images stored, worldwide is critical for making sure that you have fast time to resolution in the event that you suffer an outage in any one region. So very, very important feature. And again, we are the only cloud provider who offers anything like a geo-replicated container registry. Okay, so that's an overview of AKS and how AKS works on Azure. The next thing I want to do is take you through some of the top scenarios we find customers using with Kubernetes on Azure. So in general, we're seeing four big trends here. The first one is around lifting and shifting workloads to containers. And this is really premised around cost savings and the desire to migrate workloads off of on-premise environments. The next one is around microservices and the move to microservices, which Kubernetes is really, really well suited to do with its integrated service discovery and sort of the container model. And the motivator here is really around agility. Like, how can you move faster? How can you get distributed group of software teams to be working independently? We're seeing a lot of traction in the industry around that today. I don't have to tell anyone that machine learning is pretty hot right now. And I would say that folks are interested in sort of the performance of machine learning, as well as the ability to you have these ML models, the training and inference, running on a portable environment like Kubernetes. And lastly is IoT. IoT is also a pretty big movement right now. We have a lot of customers who are seeing some success with IoT on Kubernetes, and here the portability scenario is really important. You want to make sure that Kubernetes can work in a variety of different environments and in different edge locations, as well as on very small form factor devices potentially. So lots of interesting work here. To go a little bit more deeply into each of these, the app modernization scenario is really about trying to take legacy applications, traditionally VM-based applications, put those into containers and move them into an orchestrator running in the cloud. Now, a number of benefits to this. The first one is that you get to, in theory, deprecate VMs or on-premise hardware or some legacy infrastructure that you don't really want to have to worry about while keeping the workload. The workload will also take on some interesting characteristics. The most important of which is self-healing. So if the node that the new modernized workload is running on inside a container, if that node fails, that workload will be auto-scheduled and it will automatically come up. Yes, there may be a slight window of failure, but it's a much bigger. It's a very large improvement over what you get off of traditional VM-based infrastructure. So now, traditionally, these workloads need to be migrated along with a data store. Those data stores can either run inside of the Kubernetes service, or more commonly, they can run outside in another Azure service, like for example, Azure Database for MySQL or Azure SQL. Now, microservices are, taking the industry by storm here. If you take a look at a monolithic application, this is basically just taking an app and, spreading, a set of related chunks, across, a number of servers and you're trying to get to some horizontal scale motion. This is tricky to scale. It's tricky to scale from a technical standpoint, and it's tricky to scale from a people standpoint. The industry has been moving to microservice architectures, which, allow for these independent deployments. It allows you to structure your teams such that they own smaller parts of the code base, and you can have well-defined APIs across those teams. In this model, you're basically spreading out all the different parts of your microservice deployment across a huge pool of servers. This makes a failure of one server much less disruptive. As sort of the containers get rebalanced and rescheduled across the cluster, typically end users shouldn't notice when those failures happen. For machine learning, what we're seeing is really this desire for a data scientist in a box, right? We've had a lot of public discussions about how OpenAI is using Kubernetes on Azure to accelerate what they're doing, which is really cutting edge, model training. I think that in this case, whether you're using TensorFlow or some other solution, being able to have that, running on across a pool of nodes in Azure Kubernetes services that leverage GPUs and related hardware advancements to really burn through these model trainings is something that we're seeing a lot of customers finding success and value in. And lastly, Scalable IoT Solutions. We've had a really great partnership with the folks in the world of IoT. And so, integrations with IoT Hub, the IoT Edge connector, which, actually uses the virtual kubelet, to spin up, nodes inside of IoT Hub, integrations with Cosmos DB. I'll talk in a moment about, some of the customers that are seeing some good success with IoT on AKS. So, but before I do that, what I'd like to do is just dive into kind of the products, right? Go over AKS, go over the Azure Dev Spaces product, and take you through what this looks and feels like. So let's flip over to our desktop. All right, so let's get started with AKS on Azure. So first thing we're going to do is we're going to go click the new button in the portal, and we're going to select the Kubernetes service. Now, what you can see here is a nice, clean wizard for how you can sort of specify the form fields for this. I'm going to go ahead and put this in an existing resource group called AKS. I can name my cluster. I can select from regions. Now, we actually have 13 regions now. We just added Southeast Asia, so we're starting to get that regional spread. We should be in every region before the end of the year. I can also select Kubernetes versions. You can see we got lots of different options for versions. 110.6 is currently the latest. I can name my cluster as well. I can also select the node size. It's important to note, we default to a 1 vCPU node, but you can make this any node that you have or VM SKU that you have access to, including GPUs. For scale, I can move the slider to choose different scale types. Moving on to authentication, we can see that there's a service principal that's required. Now, this is how you get how the cluster gets access to do things like create load balancers, create disks inside of Azure. By default, we'll create a new one for you, but if you want to provide your own, you can do that. We also support our role-based authentication controls for Kubernetes. This is in preview right now, but we're going to be enabling this by default soon once it comes out of preview. On the networking side, you can see that we have this HTTP application routing feature. Now, what this does is it allows you to automatically expose your applications in Kubernetes to the public internet, should you so choose. This is important for having basically your public website exposed through the internet. What's cool about this is that this gives you a stable DNS name that you can use to access your app. Now, on the network configuration, this is something that we've heard from a lot of customers is really critical to adopting Kubernetes inside the enterprise. Now, we do support basic network configuration, which doesn't have a lot of tunables to it. But the advanced network configuration is, this is where you're able to select your, custom virtual networks. You can either create a new one or select a custom VNet that you want to attach to. You can also do the same thing for subnets. You can either attach to an existing subnet or create a new one. And importantly, you get control over the IP address ranges. Now, this is important for, if you want to have your Kubernetes cluster exposed over ExpressRoute or a VPN to on-premise. It's important in those scenarios that you don't have overlapping IP addresses. Though the service is managed, though it's a black box service, we give you control over what kind of address ranges you want to use. That way you can wire up over VPN and everything can talk to everything without any IP overlap. Now, on the monitoring front, we do enable Azure Monitoring by default and we will create a default log analytics workspace for you, or you can select your own. I'll go through what this looks like in a moment, but this is a pretty important feature for making sure that Azure has sort of the visibility and portal that customers are expecting. So excited to show some of that off. After tags, I can go ahead, specify optional tags and then hit review and create, and my cluster will be up in a few minutes. But since we don't want to wait for that, let me just go ahead and show you an existing cluster that I provisioned for this. This is the cluster right here, and as you can see that the Kubernetes version, you can see the API server address, how many cores are running, how much memory we have. If you go to upgrade in the blade, you can see that I'm currently on 1.10.5, but there is an upgrade available to 1.10.6. So all I could do here is select that, hit save, and in a few minutes my cluster will be upgraded. So pretty easy to do, especially when you compare that to what it would take to do manually. Scaling is similar. For scaling here, you can see that we're currently 3 vCPUs, an aggregate of 10.5 gigs of memory. We could choose to scale this thing up, and you can see up here, this would be 60 nodes would give us 60 vCPUs and 210 gigs of aggregate memory across the cluster. And again, just hit save, and that change will be rolled out, and you'll have a 60 node cluster in a few minutes. Now, probably my favorite feature inside the portal is the container health view. This is provided by Azure Monitor. Now, what this does is this gives you sort of aggregate view across the cluster here. So we can see that, by timestamp, we can see what our average CPU, is per node. We can see how many nodes we've had in the cluster. We can see how much memory and then active pods and different pod statuses. We can also drill into nodes, specific nodes. So if we have a node that's running hot, we can, open this up and inspect, different pods that are running. We can see, everything looks okay for the most part. I can also, if I don't want to look at a node view and I'd rather look at sort of a logical view, I can take a look at the Kubernetes controllers that are running. Now, there's an app on here, a hotels API endpoint that we're going to be looking at in a minute. If I filter by hotels, I can drill in and I can see sort of the hotels container that's running. And something I find really cool is you can actually click here to view logs, and that'll drill directly into log insights and pull out the standard out and standard error logs for your app. So that's an overview of the portal here. But interestingly, Kubernetes, while it's important to have a great experience for the cluster operator, it's critical that we have Kubernetes be something that developers can be productive on. So for the next step here, I want to show you how you use Kubernetes as an application developer. Okay, so to show how a developer would use this, I actually have an existing application that's loaded onto this particular cluster called the Smart Hotel 360 application. Now, this is actually a real example application of a hotel booking system. And if you go back to the container health view and you type in SH360, you can see that we actually have a number of different microservices that make up this particular app. Now, these all happen to be written in .NET. And they all happen to be running on AKS. Now, if you jump into GitHub, this is actually the code base that is running the service. But first, let me show you kind of how the front end of this app works. So this is sort of the main public web interface. And what I can do is I can search for a room. I can type in New York, and I can see New York pop up. And then I can go ahead and select, a date range that I want to stay, and things are good. Now, what I've learned as a developer is that there's a bug in this case. In this case, the bug is that if I type in Seattle, I don't get any search results. And that's a problem, and we need to go fix that. So I need to go figure out how to fix this bug. Now, unfortunately, I'm new as a developer to this particular code base, to this system. I don't really know Kubernetes that well. So let's figure out how I'm going to get productive and try and debug and fix this. So the first thing I'm going to do is I'm going to open up my browser here, and I'm going to go into the hotel service because I was given a hint that this problem is likely in the hotels microservice, which is what's providing the list of hotels. Because I know that I'm looking for cities, I'm going to guess that this is in the cities controller here. Now, if I take a look at what this code does, you can see that this is actually returning a list of cities. So what I'm going to do is I'm going to go ahead and add a breakpoint into this logic, and then I'm going to go ahead and run a breakpoint debugging session. Now, what this is going to do is use something called Azure Dev Spaces that's going to use a pre-configured space that I've created inside of this cluster. It's basically using Kubernetes namespaces under the hood. But what this does is it allows me to have a space where it's going to build versions of the containers that I'm working on in my IDE up in the cluster so that I can do things like breakpoint debugging against a live running environment consisting of multiple microservices. Now, this is pretty compelling. So what you can see here in the output is that we're actually compiling this .NET Core application up in the cloud, starting a debugger, and then running a custom version of this application, which is now listening on port 80. Now, what's interesting here is if I actually go in and type in Seattle, I'm not going to hit the breakpoint debugger, right? Because there's one part that I'm missing here. What I have to do is I actually have to prefix this with gabe.s, which is my space as the developer that I've created here. Now, if I query this and I type in SEA, what you'll see is that it will detect that it needs to route traffic to my version of this container, which is the one that's running this breakpoint. So now I can go take a look at the cities here, and I can see in the results that this is an empty string. So, that's interesting. So we did find the right spot in the code to debug. I'll go ahead and hit play to release the breakpoint. Now, if I look at this query, I could see this get default cities. So if I go ahead and click that, I can see this. Oh, look at that. We have 4 hard-coded cities in the code base. Someone hard-coded the cities list instead of calling out to the database. Oh boy. But I think the good news is we can go ahead and fix this. So if we go back into the cities controller and we actually change this to the right query, cities queries.get of the name that was passed, and I save that, I can go ahead and restart this debugger. And what it will do is it will recompile a version of this application with my fix in it. Now, what's interesting to note is what's not happening. What's not happening is I'm not doing a Docker build on my machine locally. I'm not pushing an artifact up to a container registry. I'm not rerunning a bunch of deployment artifacts. I'm literally just operating on the container live running inside the cluster. This dramatically streamlines the process for interloop development. We can see we have a new version of this running up here. I still have my breakpoint involved. So let's go back to this API and I'll go ahead and type in SEA. And what we'll see is the breakpoint pops again. Go back into my debugger view and take a look at this and look at that count equals 1. And we've got Seattle. So presumably the database is actually working now. So go ahead and hit play. And we'll go back to the browser and we can see, hey, look at that. Seattle comes up in the list. I've effectively fixed the bug. Though importantly, I've actually only fixed the bug inside of my branch. If I go back to the mainline branch here and I type in Seattle, it's still broken. So let's go ahead and actually roll this fix out. Let's go ahead and deploy this out to the main environment here. So the first thing we'll do is actually commit this change. We can see our modification will say use database for cities query. And we'll go ahead, got to add our commit. And then use database for query, and then go ahead and push this up to the master branch. Now, what's going to happen now is, because we've actually pushed something to version control, this is going to actually spin a build on our CI system. Now, prior to this, what I've done is I've actually configured a VSTS project for the Smart Hotel application, which is, basically running and managing all of the CI here. Now, if we go into the build and release tab, and we take a look at the Smart Hotel 360 definition, we can see that there is now an in-progress build for this latest push to master. So if we click on this, we can take a look at the output real quick. Now, I just want to point out that, though this had to be pre-configured here, this is something that can be configured automatically for you through use of the Azure DevOps project. Very fast and easy way to get up and running with an end-to-end CI pipeline. Now, while this is waiting to spin, I want to kind of walk you through how this CI was configured. So if we go back to the app on GitHub here and we go to the root of this app, we can see there's a vsts ci.yaml file here. Now, what this does is the first step is it's going to log into Azure. The second step is going to build and push the artifacts specifically for this hotel service. And then lastly, it's going to use Helm to upgrade the release in the cluster. That's going to actually roll a new version of this application. Now, there are a set of values that have to be defined CI side for things like, what the registry name is and different credentials and that sort of thing, how we log into Azure, things like that. I can kind of show you where that stuff lives. If we go back to build, can take a look at the variables. Now what I've added is, sort of the ACR resource group, AKS resource group, the subscription ID, which is a connection to an Azure subscription, as well as the registry host that we want to push this stuff up to. So now if we go back to the build output, we can see that this is currently in the process of building and pushing to Azure. We've successfully cloned the source. We've logged into Azure. We have our credentials. It's currently building images and getting these things deployed. So we'll wait for this process to complete a couple moments here. All right, now if we flip back to VSTS, we can see that actually the build and push succeeded. So we have our artifacts up in ACR, and the Helm upgrade also succeeded. This actually rolled out a new version of the Smart Hotel 360 app, the hotel's microservice of that app that has this new fix in it. So if we go back to now the mainline version, note there's no prefix for MySpace on this. We go ahead and we reload this page and type in SEA. We can see, boom, there we go. Seattle's there. We can book a night. We fixed the bug, and all is good. Now, I want to point out, just how little work was required on behalf of the developer to get up and running. All we really needed in this case was an AKS cluster, Azure Dev Spaces, and an IDE like VS Code or VS, which has this ability to do the breakpoint debugging. I didn't need to set up microservices locally on my environment. I didn't even need Docker on my environment in order to work on these and fix a bug in a production environment. So it's important to point out that part of the job of building good tools to help folks get productive with containers is making sure that they're using workflows and tools that they're familiar with and comfortable with, and things like breakpoint debugging inside an IDE like VS or VS Code is one of those things. So excited to have this out here. So so that is Azure Kubernetes Service with Dev Spaces. So I hope that demo was enlightening and showing some of the capabilities of AKS and some of the dev tooling we have around it. But next I want to talk about some customer stories and some customers who've had really good success with Kubernetes on Azure. So to start, we have Siemens Health, Siemens Healthineers. We actually built a great video on this if you want a little bit more detail, but company in the healthcare space and really using AKS to speed up their application delivery, which is a microservice-based environment. So this is a very common pattern that we see, not just in the healthcare industry, but really across the board. Ambit Energy is a interesting company in the energy space, and what they've done is use a combination of services like Kubernetes on Azure through AKS with a mix of other open source solutions like Docker, Puppet, Terraform, and Cassandra. And really for them, a lot of the focus was around cost reduction, and that's a pretty important thing in the crowded electricity market. Now, Altair is a company in the high-performance computing space, and what they were able to do is use Kubernetes on Azure, to eliminate the need for expensive engineering workstations. Kubernetes offers, a lot of the benefits that you would expect for someone who needs high-performance computing at large scale, and we're glad to see them being successful with our solutions on Azure. Varian, another company in the healthcare field, is using Kubernetes on Azure for cancer treatment technology. So, interesting here. Again, similar story around sort of agility, moving beyond virtual machines and being able to provision and update their solution more rapidly. And lastly, Falconry is a company in the oil and gas space that was really aiming to create a data scientist in a box solution. And what they were able to do with AKS is get their solution out to market in days rather than months. And this is important as a startup to be able to deliver quickly in that way. The last thing I want to touch on here is, we obviously have great products. We have a lot of customers who are, finding success in those products. But it's also important to talk a little bit about our open source culture, because after all, a lot of these technologies that we're building on are, created and derived from efforts in the open source community. So, we take community very seriously here at Azure. I myself come from an open source background. I actually came to Microsoft by way of the Deis acquisition, a little over a year ago. And we were pretty much exclusively doing open source. Brendan Burns, who is my counterpart in engineering and the co-creator of Kubernetes, also very steeped in community culture. And this is something that, we take very seriously. So lots of different things that we do. And, I want to talk a little bit about that. Azure is seeing just a ton of increasing demand around Linux and open source solutions. Linux VMs are growing at 2 times the rate of Windows VMs today. And that just goes to show Azure's strength, in appealing to sort of that, crowd of folks who are interested in Linux and open source. If you haven't heard, Microsoft announced the acquisition of GitHub, which has made some pretty big waves in the industry. And I think it just shows, really a commitment to, developers, developers as the new sort of power brokers in the industry. We're really interested in being a great platform for developers, and I'm excited to see what Microsoft has to offer there. But I do also want to point out that we have lots of different partnerships with different players. We recently announced OpenShift on Azure, which is a joint collaboration with Microsoft and Red Hat to deliver OpenShift, which is sort of Red Hat's Kubernetes solution, but in a managed form factor running on top of Azure. A lot of excitement from large enterprise on that. And if you're interested, definitely let us know. But we also offer partnerships with folks who, folks like Pivotal, who offer a really great Cloud Foundry distribution that is very attractive to folks in the Linux and open source space as well. But it's not just that we're partnering or developing products. We're actually leading in a lot of cases in these open source communities. So not a lot of people know this, but we actually have 2 members on the Kubernetes steering committee. I myself am a member of the board of the Cloud Native Computing Foundation. John Gossman is a member of the board of the Linux Foundation. We have several leads or co-leads in Kubernetes special interest groups. We really do spend a lot of our time giving back. This is also true in some of the open source code bases. Brendan Burns remains the number 2 contributor overall to Kubernetes. We have the number 4 overall contributor to the Docker project. We are really leading the charge on Helm, which is now the CNCF sort of blessed package management solution for Kubernetes. And we have 70 employees across Microsoft who have made contributions to the Kubernetes project. So that's really exciting. And another thing I'm really happy to see is that we've done a lot of work on the developer tooling side of the house in open source. Helm, the package manager for Kubernetes, Draft, Streamline Interloop tool, sort of like an open source version of what you saw with Dev Spaces. Brigade is a JavaScript-based workflow engine for Kubernetes, and the VS Code Kubernetes extension. These are all things that we have developers working on full time inside of Microsoft, and really making sure that we give back to these communities, because we really believe that in order to build really great products like Azure Kubernetes Service, we have to be giving back in these open source communities. So the last thing I want to touch on is some resources you can use. We have a series of links here that will get you access to, and I also want to encourage you to connect with us directly. You can find me at @GabberTV on Twitter, or my email firstname.lastname@microsoft.com. Please reach out to me directly if you have a question. I'm happy to answer it. The same is true for Brendan. I can tell you, I know Brendan loves to engage directly with customers. If you have questions, please just shoot him an email. We're a friendly group over here. And really, that's it for today. So thank you for joining us. Hope this was useful. And please stay on the line for a few minutes if you have any questions. We're happy to get those answered for you. Thanks so much, everyone.